Today, I want to work on taking a complex number from rectangular form to polar form and how we do this and what that process actually means. So here we have a rectangular form of the number, of the complex number, and here we have our polar form of the complex number. Now we can see a, b, I, r, and theta, right? What do these mean? Well, we know I is the square root of -1, right? But what about the a, b, r, and theta? Well, if we have some point on the complex plane, right, and let's make that a right angle, right triangle, the distance traveled on the x-axis will be our a. The distance traveled on the y-axis, or the imaginary axis, will be our b. Our hypotenuse is going to be our r. And the angle made between these two lines here, or the angle made with this line, is our theta. All right? So what we want to do is focus on having these 2 points and finding these points here. If we can do that, then we can very easily turn it to this form here. So let's start with this problem. Well, here we can see our complex plane, and our rectangular form for the number is -8 times the square root of 3 plus 8i. Well, let's draw out let's see. This is going to be in the x is negative and the y is positive area, right? So let's just say that's like approximately here. Then let's draw this out and this out. And we have our hypotenuse. Our distance made with the x-axis, or the real axis, is -8 times the square root of 3, and the distance made with the imaginary axis is 8. All right? So we want to find the hypotenuse. So how can we do that? Well, let's use the Pythagorean theorem, since this is a right triangle. If we take 8, the square root of 8 squared, plus -8 root 3 squared, right? That is also 64 plus this squared is going to be 64 times 3. Then this is the square root of 64 times 4, right? Because we add these two together, then it becomes times 4, right? That is also equal to, the square root of 64 is 8, and the square root of 4 is 2, so this equals 16, right? So we know the hypotenuse is 16, or we know our R value is 16, right? We're already halfway there. Then we can use some trigonometric functions to find out what our theta is going to be. Now, how should we do that? Well, we should take these two here, right? And we know this is along the x-axis, and along the x-axis is cosine. If you don't know this, you should probably review your unit circle, right? So if we know this is cosine, and this is sine, right? We know tan of theta equals opposite, or sine over cosine. This is our sine 8 over -8 root 3. Tan of theta equals, this is going to be, the 8's will cancel out, and we'll get 1 over -root 3. This means tan of theta equals, we can multiply both sides by square root of 3, and we get square root of 3 over 3, negative square root of 3 over 3. All right? So what do we want to do now? I want to be able to evaluate this without a calculator. So here handy, I actually have the unit circle. And what we want to do is look for which tangent actually it has square root of 3 over 3, negative square root of 3 over 3, when our cosine value is negative and our sine value is positive. Well, let's look around. This up here has square root of 3 over 3, but they're both positive. This over here has square root of 3 over 3. Our cosine value is negative, and our sine value is positive. So that looks perfect. So our angle is going to be 5 pi over 6 radians, or 150 degrees. So you can say theta equals 150 degrees. Or you can do it in radians. I'm going to do it in degrees right now, though. So let's erase this. And we can say our polar form, now that we've found what theta and r equals, well, r, we can substitute 16 cosine of 150 plus I sine of 150. So there we have our first of the two problems done. Now let's look at this one. This one is going to be a little bit more interesting because that value is 0. Our cosine value is 0. Let's draw out the imaginary or the complex plane again. Let's say, so we know that our sine has a value, but our cosine doesn't have a value. So we can say that this, let's just pick this as our point here. We know this is 10i, right? But we know that this, there's no cosine value. We didn't move along the x-axis at all, right? So our r value is actually going to be very easy to find. Our r value, remember we just used the Pythagorean theorem, but one of the values is 0, so we just square 100, and then we take the square root of 100, which is, sorry, we square 10, then we take the square root of 100, so we still are at 10. So our r value is 10, all right? But our theta is where it gets a little bit more complicated, all right? Because if we try to take if we say tan of theta equals sine 10 over 0, right? 10 over 0, you can't divide by 0. That's going to be undefined. So we're going to have to think about this a little bit if we actually want to get an answer for what our angle is. Well, if we look along the unit circle, right, we can see that our sine value is in fact positive, right? We want to look for a place where tan is undefined. Well, that's only in 2 places, and our sine value is only positive in 1, and that's when the angle equals 90 degrees or pi over 2. I'll use radians this time. So theta equals pi over 2 radians. So now we have our r value and we have our theta value. So let's erase this a little bit, and we can substitute 10 in for r. 10 cosine of pi over 2 plus I sine of pi over 2. And that's how we can convert things from rectangular form to polar form. Hopefully you enjoyed and found that interesting. If you spotted I said anything wrong or have anything additional to add, please comment that below. Thank you.